Well, good morning, ladies and gentlemen, everyone in the room, and all of those who are watching online now or later in the archives. Glad to have you with us, and it's really just great to see all the interest there is in this topic area, and we're particularly delighted in ONF to be co-hosting this with Layer 123. This is the 7th conference we have done together, and a very successful partnership that we have for really good quality conferences. So we're very pleased to continue doing this with Layer 123. I'm also pleased that the title of this conference and the one in the fall continues to be the SDN and OpenFlow Congress. We talk a lot about SDN, we talk a lot about NFV, we don't talk a lot about OpenFlow anymore, but I will today. It's important, and I'm glad it's still in the name because it's significant. So new developments in S, D, and N, it's going to be quite simple. The S, the software, is going to be what's happening in open source and its importance. The defined is going to be less emphasized, just one slide, on northbound interfaces, how you kind of define what the network can do for the applications. And then the other emphasis is on the N, the networking part, and that is OpenFlow. And so I'm going to be talking about open source and OpenFlow this morning. These are the most important areas of our focus this year. Now, Asia-Pac continues to be a world pioneer, partly because of rapid growth without the encumbrance of a large installed base in many parts of the region. Therefore, take bolder steps and embrace new technology a little bit faster. Just look at the number of new mobile access points and base stations that are installed every year in this region. It's sort of every year it grows more than some of the installed bases we have in many of the other countries. We've had a large growth in membership from Asia, led by Asia-Pac this year, including a number of significant network operators, Chunghwa Telecom in Taiwan, CFI Technologies in India, Malaysia Telecom, Tata Communications, and of course the major ones in Japan, China, and Korea. The motivations on the business side for SDN continue to grow in prominence. Deployments also continue. These are 4 areas in which we're not only seeing good use cases, we're seeing deployments, and we're seeing products to support those deployments. These are often very early stage. They're sort of cobbled together. They don't all fit our definition of open, meaning published, standard, and not controlled by a single party, but vendors are bringing solutions to the market, and the operators are starting to deploy solutions in these 4 really, really important areas. And we see tie-ins between NFV and cloud networking with SDN as an underpinning technology. And network as a service, actually it's X as a service with a variety of other words put in there besides network, a platform, NFV as a service. Pretty soon we're going to see service as a service. So what is it about OpenFlow? And why am I still talking about it? We've been talking about it for 4 years. We were formed to turn the OpenFlow protocol into an industrial strength standard in 2011 when it came out of Stanford University. We've continued to work on it. We, of course, have expanded our scope to embrace all of SDN because SDN as a concept is really important. It is the sole thing that we focus on. Everyone else touches it in some way, but typically related to something else. It is our sole focus. But OpenFlow is still the core part of it, and we have a lot of activities and investment in OpenFlow as an enabler of all of the great benefits you will hear cited today and tomorrow about SDN and about NFV. So why is it still important? First of all, it really mandates that you separate the forwarding plane from the control plane, and it is a communication mechanism between them when they're physically separated, and you may be communicating across a wire. I say that this is the key to operator transformation because it really enables you to start taking control of your own destiny in your own control programs and your own applications, not bundled into the infrastructure hardware, and to then be able to build a network based on best-of-breed purchases at every layer in the hierarchy. It's exactly what happened to the PC industry when we went from mainframes to the horizontal structure of PCs with different chips, different operating systems, different applications. This is happening in networking, and the most visionary carriers are seeing this, and they're saying, I don't want to be locked into a vertical solution or a single vendor solution. I want to be able to create my own traffic classes, my own policies, and my own security mechanisms for my customers, be they enterprises or consumers. And that goes not only for the telecom carriers, it also goes for enterprises and data center operators. They are racing against each other, and the competition is going to be determined by who is able to write the best services fastest. And they cannot do that if they have to tie that into whoever's equipment they buy. What the operators are starting to build is network infrastructure that is application independent. I just mentioned this match action paradigm. This is the essence of how we have really abstracted the forwarding plane. You get something coming in, whether it's a frame, a packet, or perhaps an optical signal. You look it up in a table. If there's a match, you take the prescribed action. It's pretty simple. But this is why OpenFlow is different from, say, NetConf and Yang, which we use actually in our configuration protocol. But as a southbound alternative, it does not advance this paradigm, which gives you the greatest flexibility, whether in either a fine-grained or a very large-grained, coarse-grained manner. You can determine how to treat the flows that are using up your resources. And as our experience increasingly bears out, the OpenFlow protocol as a mechanism for connecting the forwarding plane and the control plane is simple, it is scalable, it's extensible, and it is portable, and I'll talk just a little bit about that today. The excitement this year is it's finally coming around in hardware. I know it's been a long time, but since we've gone from 1.3 single table to the multiple tables of 1.1 and beyond, and we're up to OpenFlow 1.5, multiple tables have been hard for people to implement in existing merchant silicon. So it's finally happening this year for a variety of reasons, and not just in merchant silicon, but in some new kinds, in flexible match action ASICs. Same price performance as a fixed function ASIC, but you have much more flexibility in the number of tables and the ordering and functioning of those tables. We're also seeing, and you'll be seeing in demos this summer, OpenFlow implemented network processors and FPGAs for great flexibility in looking at not only the header fields, but also in the payload fields for matching and actions. We're finally seeing some opening up in the chipset hardware abstraction layers, not to give away all of their secrets, but in terms of an abstraction of it, and the software development kits that you're seeing coming out of some of the major vendors are a really good step in that direction. The OpenFlow data plane abstraction from Broadcom is a very prominent one, but look what's happening in the Open Compute project with their switch abstraction interface, and we're supporting these efforts. And then the notion of packet programming, kind of a new notion, maybe even up in the control plane. How do you tell the forwarding plane what its pipeline should be in terms of the tables and the order of those tables that it will implement? Right now we have TTPs which convey up what the pipeline is, but pretty soon we're going to have pipeline compilers that carry it downward. Tremendous development in hardware for OpenFlow this year. Mentioned switch portability. It's been an unfortunate fact of the market that the details of the forwarding plane and the switch pipeline have to be reflected in the controller and often in the applications. This is crazy. It's a fact of life. We are overcoming this through having a pipeline abstraction layer where you will see this in some of the popular controllers this year, where we go to the chipset vendors or the switch vendors and say, tell me what your pipeline is, put it in a driver. You put the driver up in the control plane, and then the applications, the routing, and all of the functions can be independent of your pipeline. We have an OpenFlow agent, the SDK, and whatever the chip is, down in the forwarding plane. This allows innovation in the applications and in the control plane independent of what's going on in the pipeline. It also allows the chip companies to innovate in how they build their chips. What are they optimized for? Is it for top of rack? Is it for a spine switch? Is it for a CPE switch for an enterprise? What is the price performance? How many ports at what speed? You can have free innovation now, not tied into other layers of the architecture that only slow you down. What is ONF doing about innovation in OpenFlow? Many things. This whole chart are things that we do and have been doing for 4 years and continue to do for OpenFlow. I mentioned the table type patterns in the oval at the bottom and protocol independent forwarding. in which you don't really even know what the layers are in a frame that comes in, and you don't care. You look at a certain place in the packet, whatever the protocol is, you don't even know, and you take prescribed action. You couldn't do that in fixed function ASICs, but it's coming along. And up near the top right, optical port properties. We have optical extensions, and we published a specification for OpenFlow extensions for optical, and we demonstrated it with 7 major carriers and 9 vendors, and the CATR in China in the last 6 months, showing how you can integrate packet and optical switching with a single control plane using the OpenFlow extensions for layers 1 and 2 and layer 0 for the first time. You can take a look at this. This was pretty much the big news over the winter time. This was a project we did in cooperation with the Optical Internetworking Forum. Open source is a big topic of conversation yesterday, and I'm sure it will be today and tomorrow. What's with open source? Why is it on everyone's tongue? Well, it turns out that some of these big software elements of a networking stack are not ones that every vendor needs to do differently. So if they collaborate for these pieces that don't require vendor differentiation, there are tremendous efficiencies that can be gained. The alternative is that everybody does their own, that's wasted effort, or there's a monopoly and one company does it all. That's not good for the market. It's also very hard for any one company to have the resources to build out a large and comprehensive system. We've also found that when many people come together to build an open source software component, it develops faster, you get faster feedback, it's very efficient, every company puts in 5% and they take out 100%. It's also more secure. If you've looked at some of the major open source activities, if someone discovers a bug, it's usually fixed before most people even know about it. Because it's all open, nothing is hidden, everybody knows and everybody can work on it. There are approximately 1 million open source projects that have been created since this phenomenon started. Most of them are failures, but there are some big, big successes. The ones that are the most successful are the ones that have built community and have many parties contributing. ONF has been sort of dabbling in open source for the last 2 years. One of the lessons we learned is that you can write some software, you can pay people to write it, put it in a GitHub repository, it's there. If you don't build community for it, you haven't done anybody any good. It sits there and it turns moldy. We've learned our lessons. We're doing hopefully a better job with this. In the chart here, you can see that in the networking world, there are quite a lot of open source activities. Just about every layer of the architecture, including open source hardware at the bottom. What do we make of this? Well, we make several things. First of all, there's a desire to create some common components. And there are lots of good people working on these things. ONF partners with quite a few of these, and I'll say more about that. But it's a very rich area of innovation. Some will go on to be big successes, some of them probably will not, but already a few are the big stars. Now, you can also look at this and say, gee, it's all open source. There's no room left for any creativity, for any margin, any profitability, any business success. I would disagree with you. What it really does is open up genuine opportunities where you're not reinventing the wheel. You are putting your resources where it most directly advances some technology independent of the layers above or below, and it even more importantly helps the people who use and operate networks to customize it, and in that sense it contributes actual business value. So the very first thing, the very first bullet you'll see on the right is enables you to focus your resources not on configuring the pieces of the network, but in creating new services. You'll still need engineers. They might be slightly different engineers, but this is the big opportunity. Create new services, new revenue opportunities to better serve, more individually serve your customers. I've listed a lot of potential opportunities here. One that interests me quite a lot is the disaggregation of the OSS and BSS. This is going to take some time. We're not quite sure how to get there from here, but by and large, if you can now have a control plane and some network applications that are independent software modules that determine how the paths are taken in the network for reasons of policy or security, then you don't need a monolithic OSS. The control functions that are inherent in an SDN become your OSS. I'd already mentioned things happening down in optics and in chips and in the network services themselves. A lot of interest in orchestration and automation. The open source initiatives that ONF has undertaken fall into these three important categories. We're on a journey from PDF to Python. For 4 years, mostly what we did was produce PDF. PDF-defined networking, people accused us of doing. We produced paper. Well, we're now producing software. In conjunction with many of the partners you saw on the earlier slide, we created a software leadership council made up of people who have experience in this, which we had not had. Tremendously influential and very helpful people. On the right, Bithika Kargaria is our community manager, officially director of product and community management. She still works for Extreme Networks. And in February, we launched opensource-sdn.org. This is a portal. It's open to the public. It's not member only or anything like that. It's for community projects of any size. Small inventors and creators can put projects there. We've got simple governance built in, simple licensing. And the efforts that we undertake in there and with the community are very much in partnership and cooperation with ONOS, ODL, OCP, the Open Compute Project, Open Platform for NFV, and OpenStack. Now, the one thing about NBI, 2 of the projects that we have, of probably a half a dozen or so now in opensource-sdn.org, have to do with northbound interfaces. Work that came out of our working group on northbound interfaces are going into actual code. A real-time media northbound interface, where we're partnering with the Unified Communications Interoperability Forum, which is now IMTC, and a very interesting one on intent-based, a framework actually, which has been accepted as a project in Open Daylight. It's also sort of part of how ONOS is actually built. But we're doing this in a new way to create an application that's independent of the controller it runs on by having an application engine and separate runtimes, separate code for ONOS and ODL, and perhaps others down the road. We hope this is a model for how to build applications that are independent of the controller frameworks that are now popular. And here's kind of an instantiation of everything I've talked about so far. On May 6th, there was a press release put out by the Open Networking Lab describing an intercontinental peering demonstration using BGP peering. It connected the research networks of ARNet in Australia, Australia's academic and research network, CSIRO, the Commonwealth Scientific and Industrial Research Organization in Australia, and the Energy Sciences Network in the US. The Open Networking Foundation and ON Lab collaborated on this with the 3 companies shown here, Corsa, Google, and NTT. We built the peering router on the left using ordinary servers running open source Quagga and open source ONOS controller, a Corsa switch with its pipeline driver in ONOS, connected by OpenFlow. Google built the Van der Vecken router, again, all open source except for the forwarding plane, peering with each other, advertised 15,000 routes, but in the lab 100,000 routes already, talking to the conventional BGP routers, and they did not know the difference. Tremendously exciting and successful demo. It shows what you can do with these new technologies, and this is just a drop in the bucket. So my conclusion, in 2015, we're going to see OpenFlow and open source dominating the conversation to serve the applications and to serve the use, to serve NFV, to serve OpenStack, to really harvest the results of all the people doing great work in the major network operating systems, ONOS, ODL, RIU, and even some of the other open source ones that came earlier. We continue to believe OpenFlow is really the key to OpenSDN, and as it gets more available, it will become kind of hopefully the default southbound protocol, and we'll turn our attention to creating customer value above that. We'll have it in hardware this year. That'll be a big help. And I've shown you a little bit of what we're doing to integrate. You'll see more about integration of multiple implementations in hardware of OpenFlow across a single controller framework and application framework. And with open source, there's really no faster way to gain market acceptance and feedback and to iterate on it. It's a very efficient way of applying industry resources where you do not need vendor differentiation, allows you to apply more of your valuable and expensive resources toward that sort of differentiation your customers will anticipate and benefit from. And It's hard to state how important it is to leverage community and not go out there alone. And that's a different way of operating for many of us, but it's a way we've already learned is bringing real tangible benefits to us and to our partners in the industry. We have some announcements coming up in a few weeks as we finish some of our work. Look for those at opensourcesdn.org. Join in, think about ways you might contribute. We are happy to collaborate. It's the only way we will all succeed. Thank you very much.